This presentation is to clarify the difference in the formulas used for geometric sequences and for financial math. Let's understand this by taking an example. For a geometric sequence, the first term of a sequence is 1000, and the sequence increases by 2.5% every term. Write an explicit formula for the nth term. Let's make a table of the terms and the values here. So as stated, the first term is 1000. Now the second term is 1000 that increases by 2.5%. And that would simply be 1000 times 100% plus 2.5%. Because you have to add the 1000 to 2.5% of 1000. When you write those percentages as decimals and simplify, you get 1000 times 1.025 to the power 1. The next term, the third term, would be 1000 times 1.025 to the power 2, because you simply multiply the previous term by an additional 102.5%, which is 1.025. You can keep going like this. Now notice the pattern that for the second term, the exponent is 1. For the third term, the exponent is 2. Therefore, for the nth term, the exponent is n minus 1. Generalizing this, you can write un is equal to u1 times r to the power n minus 1, where un is the nth term, u1 is the first term, r is the common ratio, and n is the number of the term. Now let's relate this to financial math with a problem that looks quite similar. You invest $1,000 at an interest rate of 2.5% per month. Write an explicit formula for the amount after n months. Let's make a table. Remember how banks work. The interest is calculated at the end of the month for the given month. And therefore, instead of term, we would write month end. So for example, the first month end would see an amount of 1000 times 100% plus 2.5%, like before, to the power 1, which becomes 1000 times 1.025 to the power 1. The second month end would be 1000 times 1.025 to the power 2, because in effect, each month you multiply the amount left over at the end of the previous month by 1.025, the multiplication factor, or the common ratio. For the third month end, it's 1000 times 1.025 to the power 3, and so on. You notice now that for each month number, the exponent is the same as the month. So in general, the formula is A is equal to P naught times 1 plus r to the power n, where A is the amount accumulated, P naught is the initial principal, R is the interest rate per month, and n is the number of months. Now, whilst these two mathematical procedures have a lot in common, they are also subtly different in the way the formula is presented. Otherwise, they are intrinsically the same. Now, for example, R in the case of geometric sequences means common ratio, whereas in the case of financial math is the interest rate per month. So it's really quite different when you consider its application in the formula. Similarly, in the geometric sequence, the term 1 starts with the initial value, whereas in financial math, the term 1, which is really the month end 1, is what you have at the end of the month by applying that interest increase of 2.5%. And so these differences give rise to formulae that are different. And so one must be careful in applying the correct formula to solve for a problem in financial math compared to a problem in geometric sequences.